All right, now we're going back to this scheduling techniques, and another techniques that we're going to use in this video is called the slack time, or how much buffer do we have until we finish that particular job. So in order to calculate this, let's take a look into this example. Use the S/O, which is the slack operation rule, to schedule the following jobs. Note the processing time includes the time remaining for the current and subsequent operations. In addition, you will need to know the number of operations remaining, including the current one. All right, so now we have A, B, C, D, E, F, and the remaining processing time is 4, 16, 8, 20, 10, and 18, with a due date given to us. Number of operations is also given to us. And now let's take a look into how we could create the sequence. So the target for us is we need to come up with this sequence right here. As you see, that's the answer. The sequence should be C, B, A, E, F, and D. All right, but let's see how we could find that sequence. Okay, we have these operations, or each of these jobs with a processing time, due date, and on remaining operations, the number of operations that we need. So the first thing that you want to do is find out the slack time, which basically how much buffer time do you have before the due date, and that can be calculated by the due date minus the process time. The due date minus the process time. So we have the due date of 14 minus 4. That will give you the slack of 10 days. So we have about 10 days to finish that job, basically. Now moving into the next activity, which is the job B, the slack would be 32 because we are needed in 32, and we know that it will take 16 days. So that would be 16. For C, the slack time is 0 because the due date is 8 and the process time is 8. So we don't have any much buffer for that. For D, we have a slack time or buffer time to be 14, the difference between the due date and the process time, 20 and 12 as well. So these are the slack time. Now let's see how we could find and rank these. This is based on the sequence of the number of operations. That would be, we use the slack time here divided by the number of operations to find what would be the ratio, the slack ratio, the slack ratio. The slack ratio right here, as you see right here, is a slack of 0 divided by the number of operations. So that would be 0. So that would be the first operations to start with, which is C. So now we came to the answer of C. Now then, we're moving into to do the calculation for each one of these, which is divided the slack time by the number of operations, this column right here, by the number of operations which is given to us here. So 10 divided by 3, that would be 3.3. 16 divided by 6, that would be 2.6. And 0 divided by 5, that's 0. 14 divided by 2, that's 7. 20 divided by 4, that would be 5. 12 divided by 2, that would be 6. And now let's take a look into this column right here and rank these jobs. So starting with C, then that would be B because it has the lowest ratio. And then job number 3 would be A, and then E, F, and D. So that would be C, B, A, E, F, and D. And now let's rank them this way: C, B, A, E, F, and D. Process time is given to us. Let's go back and calculate. It's similar to what we did on the previous example. Calculate the flow time based on these processing time. So we are starting with this one. That would be due date is process time. We are adding the 4 plus 16 to get 20 here. Because C will take us, so adding the previous time plus the next one. So for example, here the 24 is coming from 20 plus 4. Same thing here, 24 plus 10, that would be 34. And 52 plus 52 coming from 34 plus 8. And so on. So just one thing that I'm not sure about it here is just the flow time is 4 here. And I have to review my notes here why this is 4. That should not be 4. That should be it should be 8. Okay, so now this is the correct one. All right, so now this is coming from the process time, so that will take us 8 days. And now 8 plus 16, that would be 24, and then 24 plus 4, job A will be finished on day 28, and then 28 plus 10, that would be 38, and then 56, 38 plus 18, that would be 56, and then 76, which is 56 plus 20, that will give you 76. Again, the flow time, it's coming from the processing time for job by job. So for the first job, we don't have anything before it, so the process time is 8, so we will be able to finish it on day 8. And then for B, we will consider the 16 processing time. So we are on day 8 plus 16, so that would be 24, and so on. Now, the last thing that we need to do is comparing the due date with the flow time and see if there's any delay. It looks like the flow time is 8 and 8 here. There's no delay. 24 and the due date is 32. There's no delay here, so 0. The due date here would be 14, and now we are in 28, so there are 14 days of delay. And now this here, the due date is 30, and now we are on 38, so we are 8 days delays. And now moving into the next one, due date for F is 30, we are in 56, there's 26 days of delays. And for D, the due date is 34, and we are in 76. Therefore, there are 42 days delays, and we do the calculation for the 3 parameters to find out what would be the average flow, the tardiness, and the number of jobs. And then we compare it with a different sequencing or the different scheduling rules and pick the best one. All right, I hope this is helpful. We're done with the scheduling techniques. Please review these examples and let me know if you have any questions. Thank you.